Imagine waking up to the news of a catastrophic corporate data breach. Like a massive cloud provider was compromised overnight.
Oh yeah, just absolute panic everywhere. Millions of sensitive healthcare records, financial transactions, all just suddenly exposed to the web.
Right. And panic is sweeping through the entire industry. But you just sit down at your desk completely unbothered.
Because, well, your company's data is perfectly safe.
Exactly. It's safe because it physically never left the laptop sitting right in front of you. Welcome to the deep dive.
Yeah, which sounds almost like a vintage scenario going back to the days before everything was connected. But this is actually the cutting edge of data operations.
It really is. So
Mhm.
our mission today is to figure out how this system, it's called Datok, takes enterprise-grade ETL, high-end visualization, and even like AI, and completely yanks it out of the cloud.
Right, and puts it entirely back onto your local machine. I mean, we've got a whole stack of Datok reference manuals and documentation here today to unpack this.
And we're going to get into some really advanced tips from the docs today, too. But before we do, I have to ask, why do data engineers make such terrible romantic partners?
Oh, no. I don't know why.
Because they're always looking for one-to-many relationships.
Wow. Okay, that's terrible. I love it. But seriously, if you handle data, the accepted role for the last decade has been to pack up your millions of rows and just ship them off to AWS or Azure.
Right, you pay for the storage, you pay for the compute, and you just sort of blindly trust their security.
Yeah, the industry rushed towards centralization because handling massive data sets locally seemed impossible. But reading through these Datok manuals, it completely flips that paradigm on its head.
It really does ask us to reconsider the hardware we already own. Because
Yeah.
the most striking feature here is the absolute local execution.
Exactly. Every single database file, every transformation, every query, it all runs strictly out of a local directory. Like the path is literally just on your C drive.
Which fundamentally changes the economics of it. You know,
Yeah.
if you are running queries on a cloud server, you usually have these strict user quotas.
Oh yeah, bandwidth throttles, the meter is always running, you're constantly burning money.
But with Datok, because everything is isolated locally, all those artificial limits just vanish. You're only bound by your own silicon.
Right, your RAM, the processor speed, the read and write speeds of your solid state drive. But I mean, that does introduce a very real physical constraint.
Yeah, moving away from infinite cloud compute means you have to deal with, client-side memory limitations. Datok operates within a browser interface, right?
It does. It utilizes the JavaScript heap memory inside your browser.
Okay, let's pause there. Because if I am building a pipeline to clean, say, 5 million rows of financial data inside a Chrome tab, my immediate fear is that the browser's just going to melt down.
Yeah, that is a completely valid fear, and the documentation actually addresses it directly. Browsers are inherently restrictive.
I mean, they're meant for reading articles, not running enterprise data centers.
Exactly. So depending on your operating system, a single tab is capped at a strict memory limit, usually between like 1.5 to 4 gigabytes.
Oh, wow. That is not a lot of space for millions of rows.
No, the V8 engine running the JavaScript simply won't allocate more than that. If you try to force 10 million rows into active memory all at once, you will hit a wall.
And what happens? Just a total crash.
Yep, the tab crashes, and you get that classic out-of-memory error.
Well, see, that sounds like a massive deal breaker. If I spend 4 hours designing this complex transformation pipeline, a browser crash feels like it would destroy all that work.
Right, but here is where the architecture reveals its safety net. Datok intentionally separates the visual interface, the part running in the browser, from the physical database operations happening on your disk.
So even if the tab crashes, my data is fine.
Exactly. Your physical data remains entirely uncorrupted. The disk files are totally safe.
Okay, that's a relief. But you still don't want it crashing every 5 minutes while you're working.
You don't. And that's why the system provides tools to prevent this from happening during the design phase. They have these really strict downsampling protocols.
Right, I saw this in the tips section. When you are constructing the pipeline, you don't need to push all 5 million rows through just to see if your logic works.
Exactly. You use the filter or sample size functions right at the beginning of your flow. You just tell the system, hey, only process the first 1,000 rows.
Yeah, so you build your logic, you test the outputs, and once you know the pipeline is structurally sound, then you can execute the full run.
And speaking of executing the run, there's a really cool advanced feature here for workflow execution control.
Oh, right. the explicit execution control in the prep module. This blew my mind.
Yeah, instead of just hitting a giant run button and praying the whole pipeline works, processing is actually done tool by tool.
Which is so much better for debugging. You can literally step through your data transformation sequentially, see exactly what each node is doing, and catch errors before they cascade.
Exactly. It requires a slight shift in how you work, but the trade-off is absolute control and, of course, data sovereignty.
Yeah, think about it. If you're managing GDPR-compliant data or, HIPAA-protected health records, this zero cloud footprint is huge.
It eliminates a massive layer of anxiety. You bypass those agonizing legal reviews to approve a new third-party cloud vendor. The data just stays on your desk.
So let's talk about the prep module, the actual visual ETL engine, because getting data into it is surprisingly seamless.
Oh, it's incredibly fast. You can actually just drag and drop files directly onto the prep canvas.
Yeah, that's another one of the advanced tips we found. You don't have to navigate through endless import menus. You just drag a raw CSV from your desktop, drop it onto the canvas, and it auto-creates an input tool instantly.
It's so visually intuitive. The core processing engine uses this visual node graph powered by Cytoscape, which is an open source graph theory library.
And the visual cues are super clear. You have green nodes for your source files, blue nodes acting as the operational workers transforming the data.
And purple nodes are your ultimate targets, generating the final SQLite databases.
It's kind of like managing a physical rail yard. You have raw materials coming in on the green tracks, passing through manufacturing on the blue tracks, and finished goods loading onto purple freight cars.
That's a great way to picture it. And what's wild is the type of cargo this system handles natively.
Oh, man. The proprietary formats.
Right. If someone sends you a Tableau hyperextract or like an Alteryx YXDB file, you typically need to pay for a license just to open the file and see what's inside.
Which is such a pain. It's the classic enterprise software strategy, right? Locking data into proprietary formats just to force license renewals.
Exactly. But Datok just bypasses this completely. The engine intercepts those complex formats and decodes them natively into standard open-source SQLite tables.
No Tableau or Alteryx install required. That level of interoperability is incredibly powerful. But you know what really caught my attention?
What's that?
How it handles deduplication. Normally, finding duplicates is a totally destructive process. You run a query, it finds overlapping rows, and it just deletes them.
They are just gone, which from an auditing perspective is a complete nightmare.
Right. If a compliance officer asks why certain financial records were removed, telling them the system deleted them is not going to fly.
No, you need a verifiable trail. And the documentation outlines this really sophisticated mechanism for that. Datok actually splits the flow of your data into two completely independent streams.
Okay, so you get a unique output stream and a totally separate duplicate output stream.
Exactly. Imagine a massive water plumbing system. Normally, if you have a leak representing your duplicates, that water just disappears down a drain.
But here, the system pipes that leak into a completely separate, transparent bucket.
Right, but the physical separation is only step one. The critical element is what happens mathematically. The system generates a deterministic cryptographic hash for the records.
Okay, deterministic cryptographic hash, like an HMAC SHA-256. Let's break that jargon down. What does that actually do?
So think of a hash function as a highly complex mathematical blender. You feed a specific row of data into the blender, and it produces a unique, fixed-length string of characters.
And that string is your hash.
Yep. And the deterministic part means that if you feed the exact same row of data into the blender 1,000,000 times, it will always produce the exact same string.
Okay, so as our drops of water are falling into those separate buckets, the system is slapping an identical, mathematically proven barcode onto the unique drop and its duplicate drop.
Exactly. You are attaching a permanent reference key. From an auditing standpoint, you aren't destroying anything. You're preserving the unique data, but you have a trail proving exactly what was flagged as a duplicate.
And you can instantly trace them back to their origin using that shared barcode. It's brilliant. Which actually brings us to what might be the most aggressive feature in this whole Looker-first ecosystem.
Oh, the AI integration.
Yes. We are so accustomed to artificial intelligence being an inherently cloud-based service.
Yeah.
If you need an LLM to clean up messy text or extract names, you send an API call to a massive data center.
Right, to OpenAI or Anthropic. But Datok is running AI operations strictly offline.
Which is wild. How does it even do that?
It achieves this through integration with Ollama. It's an open-source framework designed to run large language models locally.
So you just drop an LLM node right into your data pipeline.
Yeah, and you can execute complex text analysis row by row, natively.
Okay, but that sounds great until you consider the hardware. Running an LLM takes serious compute power. If I'm on a standard corporate laptop, is this even remotely possible?
The manuals actually provide a very realistic hardware matrix for this. It really all comes down to parameter size.
So on a standard business machine, just using the CPU and regular RAM,
You're not going to run a massive reasoning model, no. But you can easily run lightweight models, like 1 to 3 billion parameters. For example, Llama 3.2, the 1 billion parameter version.
and honestly, a 1 billion parameter model is still incredibly capable for structured tasks. Like if you just needed to standardize state abbreviations in a messy column.
Exactly. A small model handles that rapidly without taxing the CPU to the breaking point. And as your hardware scales, so does the capability.
So if my machine has a dedicated graphics card, like a mid-range one with 6 to 8 gigabytes of VRAM,
Then you step up to the 8 billion parameter models. Those are robust enough for complex sentiment analysis. And if you have a high-end workstation with massive VRAM, the system natively supports those massive 70 billion parameter models.
and those directly rival the commercial cloud APIs. The flexibility there is just key. You can feed your company's most guarded secrets into that LLM node, and 0 bytes are transmitted to an external server.
It's totally locked down.
So let's look at where we are. The data has been extracted, proprietary formats are cracked, duplicates are cryptographically isolated, the AI has categorized everything, and it's all packed into a local SQLite database.
Right. But raw tables are completely useless to a business executive. Data doesn't make decisions. People do.
Exactly. We need to visualize it. And actually, before we jump into the visualization module, there's another advanced tip we need to cover about the prep outputs.
Oh, right, the SQLite views.
Yeah, you don't just have to output flat tables. You can actually create SQLite database views, including complex joins, right inside the prep outputs.
Which is incredibly efficient. Because instead of duplicating data across multiple flat files, you build a dynamic view. And then you can use that view directly as an input in the Analyze module.
It saves so much disk space and keeps the logic centralized. Speaking of the Analyze module, the visual environment here is really interesting.
Yeah, it's built on a highly structured 12-column grid system. This just ensures that when you build dashboards, all your charts, scorecards, and pivot tables maintain strict alignment.
The geographic visualization caught my eye immediately. They use these gorgeous, dark, modi, quertangular world maps.
And beyond just looking sleek, they solve a massive headache in data mapping, which is translation tables.
Oh, I hate mapping. It's usually this tedious process of standardizing location names. If your database says USA and your software expects United States, the data point just vanishes.
Right, and building those manual translation tables takes hours. But Datok auto-detects UN M49 levels.
So if your dataset contains standard ISO country codes, the system just plots them instantly.
Instantly.
Yeah.
No manual mapping required. It just knows the geometric boundaries for those codes out of the box.
That is a lifesaver.
Hmm.
But let's look at the mathematics behind these dashboards, because the documentation goes heavy into the LO fixed syntax.
Level of detail expressions. They are critical for advanced analysis. To really understand why, you have to look at how a standard pivot table works.
Okay, so a normal chart calculates data based solely on what is visually represented on the screen, right?
Right. If you filter a chart to only show sales in California, the total sales number recalculates to only reflect California.
But what if I need a column that shows California's percentage of the national total?
In a standard system, the moment you filter for California, the national total disappears from the math. So California suddenly looks like 100% of your sales.
Which is just mathematically wrong.
Exactly. And that is the exact problem LOD fixed solves. It allows you to anchor a calculation to a specific dimension, in this case, the national total.
Regardless of how the user filters the dashboard visually.
Yep. The math runs totally independently of the visual slice.
That prevents the need to build a dozen different charts just to show regional comparisons. It's brilliant. But even with perfect math, we still face the oldest problem in data engineering.
The language barrier.
Yes, the barrier between the IT department and the business team. An engineer builds this brilliant pipeline, but they name the crucial output column something like, custard fin V.
And the executive opens the dashboard and has absolutely no idea what that means.
Right. How does Datok handle that?
The system tackles this with a dedicated business glossary called the Legend module. It allows the creator to assign nice names to technical fields.
So you take custard fin 2 and just mask it with the label customer financial identifier.
Exactly. And the crucial distinction here is where that metadata lives. In most companies, those definitions are buried in a separate wiki page.
Or a PDF that no one has ever read.
Right. But Datok binds the glossary directly to the local SQLite database file. The context is permanently attached to the data.
You can also assign a specific data steward to a metric, right? Like the name of the person responsible for that calculation is listed right next to the chart, which completely eliminates those endless email chains trying to figure out who owns a specific metric.
It does. Now, speaking of ownership and automation, what if you don't want to run all these pipelines manually every time?
Oh, right, the fourth advanced tip, the datok.eu desktop wrapper.
Yeah, if you want to automate this whole process, you don't need a cloud scheduler. You just use the local desktop wrapper.
It lets you monitor your local resources, check your RAM usage, and you can actually schedule workflows to run automatically.
The only catch is that the desktop wrapper needs to be running continuously on your machine for the schedule to trigger. But as long as it's open, it handles the automation completely offline.
That's amazing. But, this brings us to the ultimate paradox of this entire system.
What's that?
We have spent this whole time establishing that Datok's power comes from isolation. Everything is locked securely on your local hard drive.
Right.
But business intelligence is inherently collaborative. I need to show this dashboard to the CEO or to an external auditor. How do I share an isolated environment without breaking the privacy model?
Well, the historical solution is forcing everyone to buy the software, right? You purchase fewer licenses for the executive team, and IT spends a week installing the app on 30 different laptops.
Which nobody wants to do.
No. So Datok takes a radically different approach with the standalone report container. It generates a single file ending in .datok.report.
Let's dissect this container. When I hit export on my dashboard, what exactly is being packed into that single file?
It packages everything. The raw SQLite database is compressed and base64 encoded.
So it basically turns the entire database into a long string of text.
Essentially, yes. And the container also includes that 12-column grid layout you designed, every active global filter, and the entire business glossary we just talked about.
Wow, all wrapped into one file.
Yep, wrapped into one highly compressed, encryption-ready JSON file.
Okay, so I take this single file and email it to my CEO. But they're sitting on a laptop with no database software installed. They don't have Datok.
Right.
How do they query a base64 encoded SQLite database? Doesn't there have to be a server somewhere executing the SQL commands when they click a filter?
This is perhaps the most brilliant engineering choice in the platform. There is no server.
Right, really?
Really. Datok provides a free interactive viewer, which is literally just a static public web page. The executive simply drags and drops the .datok.report file onto their browser window.
But if they drop the file onto a public web page, isn't the data being uploaded to the web? That defeats the entire premise of absolute privacy.
0 bytes are uploaded. The web page is fundamentally just an empty shell. When the file is dropped, it is parsed and queried entirely within the executive's own browser's local memory.
How is a browser doing database parsing without a backend?
It's made possible by a technology called SQLite WebAssembly, or OSM.
WebAssembly. Okay, that's one of those terms that gets thrown around a lot in engineering circles. How does it function in this specific scenario?
Well, browsers were originally built to read basic text and images. Over time, they learned to run JavaScript for basic interactivity. But JavaScript is slow for heavy mathematical lifting.
Like?
WebAssembly is a modern web standard that allows high-performance compiled code like a full database engine to run natively inside the browser at near desktop speeds.
So the browser itself literally transforms into the database server.
Precisely. The viewer web page acts as an offline worker thread. When the CEO clicks on a chart to filter for the fourth quarter, the WASM engine executes a genuine SQL query against the database that is currently sitting in their computer's active RAM.
And it calculates the new numbers instantly and updates the visual chart.
Exactly. They get the full interactive experience, cross-filtering, hover tooltips, searching the data glossary, all executed entirely on the client side.
No cloud uploads, no expensive user licenses, no waiting for IT to provision access. It completely solves the distribution dilemma while keeping that air-gapped security model intact.
It really does. It's incredibly elegant.
So when you step back and look at the whole picture, Datok is taking the immense computational power of modern cloud environments' complex visual ETL pipelines, robust AI text processing, interactive dashboarding, and constraining it within the safe boundaries of your local hardware.
It basically leverages the latent power of the processor sitting idle on your desk.
Exactly. It respects your time, it respects your computer's limits, and most importantly, it respects your data privacy.
Which leaves us with a pretty fascinating prospect to consider. I mean, the tech industry is currently pouring billions into constructing massive data centers, right?
Oh, absolutely. Pulling immense amounts of power from the global energy grid.
Yeah, and it's all based on the assumption that computing must remain centralized. But if a fully functional, enterprise-grade business intelligence suite, complete with AI integration and massive data pipelines, can execute entirely within the memory constraints of a local browser tab,
Right.
what does that mean for that trillion-dollar infrastructure? If developers can optimize tools to run this efficiently on consumer silicon, perhaps the next great technological leap won't require building bigger server farms. Maybe the future of computing is simply unlocking the supercomputers we've already purchased, sitting quietly on our desks.
Something to really think about as you navigate your own data this week. Thanks for joining us on this deep dive.